Good day, everyone. At this moment, we are now on week 2 of our third quarter, and we have been talking about triangle inequality theorems, its illustrations, and its applications. Competencies, which are popularly known as the Melcs, or the most essential learning competencies. You might be wondering why we have always been talking about Melcs, or the most essential learning competencies. Now, new normal students, these are the necessary competencies which you would surely go through in life. Everything that we have been doing are very necessary competencies in mathematics. Now let's go to our objectives for the day. At the end of the lesson, the students should be able to prove inequalities in a triangle. Now, what are those triangle inequality theorems? Let's go to triangle inequality theorem number 1. This is known as the side angle inequality theorem. It says, if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Let's have this as our first proof. Given triangle LMN, where Ln is greater than Lm, and we have to prove that the measure of angle LMN is greater than the measure of angle LNM. We are talking about this angle here. This angle M, we have to prove that angle LMN or angle M is greater than the measure of angle LNM. Now, in order to prove this, we have to do a construction. We have to construct a segment MP. Okay, this is our segment MP. Now, what would be our first statement? Remember, students, in our proving, there are two known ways of proving any mathematical proofs. The first one is by the two-column proof, and the other one is by the paragraph form. For this example, we will make use of the two-column proof. Now, the two-column proof consists of two columns. The first column consists of the statements, and the second column consists of the reasons. Now again, we want to prove that this angle LMN is greater than angle LNM. What would be our first statement? Of course, our first statement would be LM is congruent to LP, and the reason is that by construction. Okay? Next. Statement number 2 is that triangle LMP is isosceles because the definition of an isosceles triangle states that if the two sides are congruent, then our triangle is an isosceles triangle. Next. Statement number 3 states that angle 1 is congruent to angle 2. Since this is an isosceles triangle, then the base angles of this triangle are congruent. Now, for statement number 3, we have angle 1 is congruent to angle 3. Angle 1 plus angle 3 is equal to the measure of angle LMN. Okay, this angle here, angle LMN is equal to the measure of angle 1 plus the measure of angle 3, and the reason for that is by the angle addition postulate. Now let's go to statement number 5. Statement number 5 then follows that angle LMN is greater than angle 1 because of the property of inequality. Statement number 6 states that since the measure of angle 1 is congruent to the measure of angle 2, therefore, from statement number 5, if angle LMN is greater than angle 1, therefore, it follows that angle LMN is greater than angle 2, and that is by the substitution property. Statement number 7, the measure of angle MPN plus the measure of angle LNM plus the measure of angle 3 is equal to 180 degrees. And what is the reason? That the sum of the measures of the interior angles of a triangle is 180 degrees. Statement number 8, that the measure of angle 2 plus the measure of angle MPN, these two angles here, are otherwise known as a linear pair, therefore its sum is 180 degrees. And the reason? Because of the linear pair theorem. Remember that if two angles form a straight line, then its measure is 180 degrees. Now let's proceed to statement number 9, that the measure of angle MPN plus the measure of angle LNM plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle MPN. Where was this taken? From the previous statements. By the transitive property of equality, then we can say that these two statements are equal. Next, for statement number 10, we can then now say that the measure of angle 2 is equal to the measure of angle LNM plus the measure of angle 3. What happened? Because by the subtraction property, the measure of angle MPN is equal to the measure of angle MPN. So when you subtract both measure of angle MPN to both sides of the equation, then it cancels out. Then you come up with only the equation, the measure of angle 2 is equal to the measure of angle LNM plus the measure of angle 3. Again, that property is the subtraction property of equality. Next statement then says that since the measure of angle 2 is the sum of the measures of angle LNM and the measure of angle 3, therefore it follows that the measure of angle 2 is greater than the measure of any of its angles, which is either the measure of angle LNM or the measure of angle 3. Again, that property states that the sum is always greater than its parts. Okay? And that is also a property of inequality which has been discussed to you previously by your teachers. Okay? That would be statement number 11. And then for statement number 12, therefore, the measure of angle LMN is greater than the measure of angle LNM. Remember that angle LMN is the measure of angle LMN. Okay, and that would be the measure of angle 2. From statements number 6 and number 11, this is by the property of inequality. Okay, that the measure of angle LMN is greater than the measure of angle LNM. Now, finally, we have already proven that our angle LMN is greater than the measure of angle LNM because the side opposite angle LMN, which is LN, is longer than the side opposite our angle LNM, which is LM. So we have already proven our first example. Okay, now let's proceed to the second triangle inequality theorems. And this is otherwise known as the angle side inequality theorem. It says, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Let's try to prove this. Okay? This time you are given a triangle which has angle A greater than angle C, or the measure of angle A is greater than the measure of angle C. Now, we are going to prove that side BC is greater than the measure of side AB. Okay, let's proceed to our proving. Now, this time I will be making use of the paragraph form. Our earlier example, I made use of the two-column proof. This time, I will make use of the paragraph form. Again, we are given a triangle ABC where angle A is greater than angle C. And we are to prove that BC or side BC is greater than side AB. This side here, this side AB, and this side BC. Okay. Now, we will have three assumptions. Our first assumption is that BC is equal to AB. Our second assumption is that BC could be less than AB. And our third assumption is that BC may be greater than AB. Now let's go to our first assumption. That's letter A. Suppose BC is equal to AB. Now this side here, BC, is presumably equal to side AB. Then, by the isosceles triangle theorem, angle A is congruent to angle C. But this contradicts our given information because our given information states that angle A is greater than angle C. Therefore, if BC is congruent to AB, then it cannot be. It is not possible. Okay? Now, let's go to our second assumption. Suppose that BC is greater than AB. Then, angle C is greater than angle A by the side angle inequality theorem. This also contradicts the given information. Therefore, we can say now that BC is greater than AB. Now, let's go to triangle inequality theorem number 3, which is otherwise known as the hinge theorem. Now it says, if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. This is the hinge theorem. Let us try to prove this by a given figure which states that we have two triangles, triangle FDE and triangle TRS. It says RT is congruent to DF, RS is congruent to DE, and angle R is greater than angle D. Now we have to prove that ST or side ST is greater than side EF. Now let's use again the two-column proof. What would be again? We are given RT congruent to DF, RS congruent to DE, and we are to prove that side ST is greater than side EF. Okay, so let's have statement number 1. So, of course, our statement number 1 is always the given statements. RT is congruent to DF, RS is congruent to DE, angle R is greater than angle D. What would be our next statement? Statement number 2 states that ST is greater than EF. Why did you say so? Because it says that the side opposite the larger angle is longer than the side opposite the smaller angle. Yes, that's correct. That is a triangle inequality theorem which we had previously studied. Okay, so now let's go to the fourth triangle inequality theorems. that is S sub 1 plus S sub 2 plus S sub 3. It says, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Let's have an example for us to prove this. We are given triangle LMN. We are to prove that the sum of the two sides is greater than the third side. MN plus LN is greater than LM, or MN plus LM is greater than LN, or LM plus LN is greater than MN. Now again, this is a property of equality in which the whole is greater than the parts. Okay. Now, again, we'll do construction here. We're going to construct another triangle, PLN, okay, adjacent to triangle LMN. Let's try to prove this. Let's have statement number 1. Yes, our statement number 1 by construction is we have PL congruent to LN. Okay. Statement number 2 is that triangle LNP is isosceles. Why? Because the two sides are congruent, and because by the definition of an isosceles triangle, if the two sides of a triangle are congruent, then the triangle is an isosceles triangle. Let's proceed to statement number 3. Statement number 3 then follows that angle 1 is congruent to angle 2. Since that triangle is an isosceles triangle, then it follows that the base angles of an isosceles triangle are congruent. Now let's proceed to statement number 4. Angle LPN is congruent to angle MPN. Okay, we are talking about the same angle here. Angle LPN, angle MPN by the reflexive property of equality. We talk about the same angle there. Let's proceed to statement number 5. Therefore, angle 1 is congruent to angle MPN, okay, by the transitive property of equality. Statement number 6 states that angle MNP is equal to the measure of angle MPN plus the measure of angle LNP, that is by the angle addition postulate. Statement number 7 says angle MNP is equal to the measure of angle LNM plus the measure of angle MPN by the transitive property of equality. Then number 8 follows that the measure of angle MNP is greater than the measure of any of its parts, which is the measure of angle MPN, and that is by the property of inequality. Statement number 9. Therefore, MP is greater than MN because MP is opposite the greater angle, which is angle MNP, and MN is opposite the other angle, angle MPN, and that is smaller than side MP. That is by the property of inequality. Remember, we have talked about that already a while ago. And then number 10, MP is equal to PL plus LM by the segment addition postulate. Then it follows that MP is equal to LN plus LM from statement number 1 and number 10 by the substitution property. And statement number 12 then follows that LN plus LM is greater than side MN from statements 9 and 11, and that is by the substitution property of equality. We have now proven that LM plus LN is greater than side MN. Okay? Now let's proceed to our next triangle inequality theorem, which is called the exterior angle inequality theorem. Now it says that the measure of an exterior angle of a triangle is greater than the measure of either remote interior angles. Now let's have this as our example or our proof. Let's assume that we are given triangle element with exterior angle L and P. Okay, now we are to prove that the exterior angle L and P is greater than the interior angle MLN. Okay, now again, we can prove this by construction. We're going to construct another triangle MRN, okay, so that we can prove this. Now, to construct another triangle MRN, where MQ is congruent to QR and LQ is congruent to QN. That would be our first statement. Again, this is by construction. Next, let's go to statement number 2. Notice that we have two intersecting segments here, segment LN and segment MR. Now remember, if we have two intersecting segments or lines, we can come up with vertical angles. This time, the angles we're talking about are vertical angles 3 and 4. And of course, they are congruent because they are vertical angles. Let's proceed to statement number 3. Since sides LQ is congruent to side QN, and side MQ is congruent to side QR, and its included angles 3 and angle 4 respectively are also congruent. Therefore, our triangle LQM is congruent to triangle NQR by the SAS congruence theorem. Now, if these two triangles are congruent, therefore, its corresponding parts are also congruent, then we can say that angle MLN is congruent to angle 1 by the SAS congruence theorem, and because corresponding parts of congruent triangles are congruent, or CPC-TC. I know you know that already. Let's proceed to number 5. So we will have now angle LNP is congruent to angle 1 plus angle 2. This is by the angle addition postulate, this angle here, LNP. And next statement states that the measure of angle LNP is greater than the measure of angle 1 because angle LNP is the sum, and its addends or its remote interior angles are angles 1 and 2. Therefore, angle LNP, which is an exterior angle, is definitely greater than its interior angle, which is angle 1, and this is also discussed as one of a property of inequality. So we have now proven that angle LNP is greater than the measure of angle 1 or the measure of angle MLN. Okay, now, so that we're done with our lesson. Now, thank you very much. I want you to answer the learning tasks which will be provided by your teacher through the LAS or the learning activity sheets. And be sure to answer all the activities and do not hesitate to play this video again if you have any clarifications. Thank you very much and good luck.